Looking at number 5, which says how much energy is required to heat 75 grams of water from negative 15 degrees Celsius to 120 degrees Celsius. So I'm solving for energy. I'm looking for Q. 75 grams is my mass, and I have 2 temperatures over here. To label everything I'm going to use, my next step is to create my graph. So I have negative 15 degrees, and I have 120 degrees Celsius. Next, I need to see if my melting point and boiling point will fit in here. So I'm dealing with water. My melting point is 0 degrees, and my boiling is 100 degrees. Okay, so both of them fit in there. I'm doing a heating problem, which means my lines are going to be straight, but they need to be staggered so I can draw upward lines and going in the positive direction. So next I'm going to label A, B, C, D, and E. Okay, this is going to be a longer problem because it's 5 steps. Oh, I'm going to start with A over here. So A is my solid phase, so Q equals M times CPS times delta T solid. My mass is 75 grams times CPS, which is 2.06 joules per gram degrees Celsius. And my change in temperature is final 0 minus negative 15, which is 15 degrees Celsius. Once again, you should notice that your change in temperature is going to be positive because you're doing an endothermic reaction. This whole equation should give you a positive answer. So you're gaining heat. If I multiply those across, 2,317.5 joules. I want kilojoules. I'm going to move the decimal over. And I'll get 2.32 kilojoules. Okay, I like to round to the hundredths. Next, I'm going to do B. B is when we're melting, so we're looking at the heat of fusion, so HF times N. HF, you can look at the top, which is 6.02 kilojoules per mole. Now N is for moles, so to get moles, we're going to have to do 75 grams of water for 1. So we have to convert it to moles using stoichiometry. Okay, and with that, we're going to get 4.17 moles. Our units will cancel out to leave us with kilojoules, and we'll get 25.10 kilojoules. I'm going to do C now. So C is when we are in our liquid phase. So we're going to go Q equals M times CPL times delta T in the liquid phase. So our mass is 75 grams times our specific heat for liquid is 1.87 joules per gram degrees Celsius. And remember, this is just for specific heats of water in these different stages. If it was another substance, you'd have to look up that substance. Our change in temperature here is 100 degrees minus 0 degrees, so it's 100 degrees. If we multiply all that together, we'll get 31,402.5 joules. Move my decimal again. I'll get 31.40 kilojoules. Ooh, already feels like we did a lot. Okay, I'm going to do part D on the side here so we can still look at our graph while doing our math. That is when I'm at my evaporation, so I'm going to use HV times N. HV, if you look at the top, is 40.7 kilojoules per mole. Our mole amount we already found earlier doing this math, so that's 4.17 moles. Multiply that together, we get 169.72 kilojoules. Okay. And then lastly, we'll do part E when we're in gas phase. So Q equals M times CPG times delta TG. So our mass is 75 grams. You're going to look up the specific heat of gas for water, which is 1.850 joules per gram degrees Celsius. And our change in temperature is 120 minus 100, which is 20 degrees Celsius. If we multiply all of these together, we're going to get 2,775 joules. We want kilojoules. So that's going to be 2.78 kilojoules. Okay, notice I round all my numbers to the hundredths place. So you can pick where you want to round them, but just be consistent with your rounding. So the final step here is to add them all together. So Q total is going to be 2.32 plus 25.10 plus 31.40 plus 169.72 plus 2.78. And those added together will give us a final answer of 210.39 kilojoules. Okay, and it's positive. Where you're heating, where you're absorbing that heat, okay, because we're going from solid to gas. We're taking in heat, so we get more motion in our particles. So endothermic reaction, positive answer.